In this programming tutorial, I'm going to show you how you can solve the coding problem to sum. It is a very common interview question that often appears in Google's, Apple's, and Amazon's coding interviews, so it will be helpful for you to prepare in advance. I'll start with a whiteboard explanation of the problem, then the brute force solution, the ways you can optimize the runtime complexity, and eventually I'll show you the coding implementation in JavaScript and Python. The task description goes like this. Given an array of integers, nums, and an integer target, return indices of the two elements such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. So the first thing we want to do is to start with an example and some understanding of what is really required from us. The example array is 2, 7, 11, 15, and the example target is 9. Then you can move on to the constraints and see that we are guaranteed that there's only one solution. So there is only one pair of elements that add up to the target. The brute force solution to this problem is a nested loop. So for each element of nums, you will go in and you will analyze all the other elements to see whether this element, when combined with the next element, adds up to the target. So in pseudocode, it would be something like for I equals 0, I less than num's length, and an internal loop for j equals 0, j less than num's length, j plus plus. And then if nums I plus nums j equals target, then return an array of I and j, which are the indices of the two array elements that add up to target. However, it's important to notice another constraint from the task description. I cannot equal j. So if you have something like nums of 5 to 8, 5, and the target 10, the answer cannot be 0 and 3. No, sorry, it's nonsense. I mean, the answer cannot be 0 and 0. The answer will be 1 and 2. So the function toSum should return 1 and 2. The complexity of such a brute force solution is O(n squared, where n is the length of the array nums, because for every array element, you're running n iterations to determine whether there are any other array elements that help us get to the target. Now that we have the brute force solution, let's think of how we can improve this one. And get something better. We'll call it brute force here. Now this brute force solution can be optimized, and we can optimize it by using a data structure that's called a HashMap. In this HashMap, we will store all of the array's elements plus their indices. We'll start an example with the same array, 2, 7, 11, 15, and the same target, 9. Now we just need one loop where we will put And each iteration will put a new map entry, which will use nums I, current array element, as a key, and the array index, and the index of this element as a value. Then we can have another loop, not the nested loop anymore, where we go from 0 to the same nums dot length. And we start by calculating the companion element for the current element. The companion would be target minus the current array element, nums I. And then if a map already has such an element, map of com, then we will return an array of map com and then I. We got rid of nested loops, so the computational complexity of such an optimized solution would be O of n, but we have introduced the map, so our space complexity will be O of n as well. And the original brute force solution has constant space complexity. We have not used any extra space there. So let's see how it all transitions into JavaScript and Python code. As planned, we start by declaring a constant map, which is a plain JavaScript object. And then we have a for loop where we fill this map with values. And then a second loop that looks up this map for a companion element. And if such an element exists, then we will return the two indexes, which are map com and I. I'm going to run it against the test cases. How do I do it? Okay, of course, run, pending. And I got wrong answer, target 9, output 0, 0. Of course, because I have not accounted for something important. Okay, there's equals here instead of minus. Rerun. And once again, I have missed the important part of the puzzle, which is the math com is not equal to I, because we cannot use the same array element twice. Submit. The submission was accepted, the runtime is good, and the memory is bad, but I believe it's fine. The difference is negligible, 42 megabytes versus 45 megabytes of memory. Now let's try to do this in Python. Choose Python 3, and we will implement the same algorithm. So in Python, our map will actually be a dictionary. And the syntax of for loop is a little bit different, where we use index and num. Let's actually say I here. In enumerate nums, say map of num equals I. then another for loop, which is essentially the same syntax for inum in enumerate nums. If map, we actually start with calculating this. Companion equals to the target minus num, and then if map of num. So now we say if companion is in the map, and map of companion is not the same as I, turn the return map of comp and I. We run it, it's successful. Now let's try to submit. Pending. The runtime is pretty much the same as the JavaScript solution, and the memory utilization is much better. It's not something that we can really control here. However, there's a bonus thing here. One thing that we can do is to actually use one loop. Instead of having one loop to fill in the map and then the second loop to iterate over this map, we can just use one loop. So here, I'll still do all the same, but then I will say else. And here, if we don't find the result, we're going to add a new map entry. Rerun, check that it still works. It works, submit it, and it's pretty much the same, but it still works, and it's one less loop. So it is a tiny bit better. Thanks for watching. This has been Leetcode problem number 1 to some.